Alright guys, so let's solve the previous questions and also the test questions. Now the first question I have here says list all the colligative properties. I believe this is a very easy one. Now one of the colligative properties is what? Vapor pressure lowering. Okay, vapor pressure lowering. The second colligative property is boiling point elevation. Boiling point elevation. Then we have freezing point depression. We have freezing point depression. And then we have osmotic pressure. So these are the colligative properties. I believe this is not new to any one of us. Boiling point elevation, freezing point depression, and osmotic pressure. Now the next question says a solution containing 0.22 gram of benzathine penicillin G. So our small w in this case is 0.223 gram in 1000 gram of benzene. So the weight of solvent is 1000 gram, has a freezing point constant. The freezing point constant is 5.12 degrees Celsius per mole. What is the molecular weight of the organic compound? Now the organic compound, the molecular weight is unknown. What is the freezing point of the solution? The freezing point is also unknown. So we can say the freezing temperature Tf is unknown. So how do we solve a problem like this? We are asked to calculate for the molecular weight. Now the formula for freezing point depression the other time is change in T is minus 1000 or minus 1000. Then we have Kf W all over M, then big W. Now if we are looking for M, it becomes minus 1000 Kf. We have W all over change in T, then we have big W. So our M is equal to, what do we have here? 1000. Kf is given as 5.12 times small w is given as 0.223. What is our change in T? Was change in T given in the question? Say a solution containing, what is the molecular weight? Now change in T was not given in the question. So how do we calculate for our change in T? Now the main question we have here says has a freezing point of 0.00124 below that of the pure solvent benzene. The freezing point of benzene was given as 5.50 degrees Celsius. So what is the molecular weight of the organic compound? So in the main question, I believe that here there was a mistake, so it was corrected. So in this question now, the change in freezing point was given, and then change in freezing point is 0.00124. Now this negative is just telling us that there is a reduction in the freezing point. You may not need to put it. Then times Rw is the mass of the weight mass of benzene that was used, which in this case is 1000 gram. So now if you simplify, what is this going to give to us? Now when you simplify this, you are going to get 920.77 gram as the molecular weight of the organic compound. Let's see if we are correct in our calculation. Now if everything is correct, that means this is what you are going to get. Now the next question says what is the freezing point of the solution? Now we know that change in freezing point, which is change in T, is equal to, now for freezing point is depression, so the freezing point of the pure solvent is always higher than that of the solution. So if we say this is freezing point of solvent minus that of solution, so freezing point of solution, now if this one comes to this side, becomes freezing point of solution, which is the temperature, is equal to freezing point of solvent minus the change in freezing point. So T of solution now would be equals to T of solvent was given as 5.5 degrees Celsius, pure solvent, which is this, okay, minus the T, change in T was given as 0.00124, and then the freezing point of the solution would be equal to 5.5 minus 0.00124, and this gives us 5.49876 degrees Celsius, and that is the correct answer to this question. Now this value here is unusually high, but we have to manage it like that. So usually high, which is this 920. So usually high. I don't know if there are some conversions that need to be done here. I don't think there is anything that needs to be done here. Everything is in line, okay? So let's look at the next. Which of the following is the odd term in thermodynamics? You have osmotic pressure, enthalpy, entropy. Which of these terms is odd in thermodynamics? You have osmotic pressure. Now, odd, enthalpy, entropy, exothermic are terms in thermodynamics. Osmotic pressure is not a term in thermodynamics. Hence, the correct answer is option A, because you are looking for the odd one. Now, the next question says, concentration can be expressed in weight by weight, volume by volume, molarity, all of the above. The correct answer is all of the above, because they can be expressed in weight per weight, volume per volume, and molarity. In colligative property, non-volatile solute in solution neither dissociates nor associates. That is the correct answer, option D. They neither dissociate nor associate. L-iso is directly proportional to the, now we are told that the freezing point lowering is equal to LC, right? Where L is the L-iso we are talking about. Now, if you want to make L the surrogate of the formula, divide both sides by what? C. C cancels C. Rather, your L is equal to change in T all over C. So we can say that L-iso is directly proportional to change in T, but inversely proportional to the concentration. So it's directly proportional to the lowering of the solution, or freezing point lowering of the solution, not the concentration. It's inversely proportional to concentration, but directly proportional to the lowering of the solution. Okay, so that makes option C the correct answer. Now the next, in thermodynamics, a system is in equilibrium when the Gibbs free energy of the reactant is equal to the Gibbs free energy of the product. Now you have a question here. The question says the freezing point of pure camphor, the temperature, freezing point of pure camphor is 178.4 degrees Celsius, and its molar freezing point constant Kf given as 40 degree per kg per mole. Find the freezing point of a solution containing, now the solution is 1.50 gram, which is our small w equals to this, containing 1.50 gram of molecular weight 125. Now the molecular weight is given as 125 in 35 gram of camphor. So the molecular weight of camphor itself is 35.0 gram. What is the relationship? We say change in T is equals to what? 1000 kf w all over, there we have small m, then big W. So what are we looking for? Say find the freezing point. So let's look for change in T first. Change in T is equals to 1000, kf is 40, w, small w is 1.5, divided by m is small m is 125, times big W is 35 gram, and then your change in T is equals to, when you punch this your calculator, so our change in T is 13.71 degree Celsius. Now the question says find the freezing point of the solution, but we know that change in T is equals to the freezing point of the pure solvent minus that of solution. Okay, so to get the freezing point of the solution, we now say freezing point of solution is equals to freezing point of pure solvent minus change in T. Now say the freezing point of pure camphor, so the freezing point of the pure solvent is 178.4 degrees Celsius, minus change in T is calculated as 13.71 degrees Celsius. When you punch this your calculator, going to give you 178.4 minus 13.71, which will give us 164.69. Okay, and that makes 164.69 degrees Celsius. And that is the correct answer to this question. So these are basically the test questions in previous years, and these are the answers to them. Let me go through them again. If there's any mistake, all these are correct. I know this particular question